Assalamu alaikum everyone. Welcome in the second lecture. I hope the previous lecture is clear, and but still, if you find any problem in the previous lecture, so I will be happy to answer during the class time, and try to participate in the class on Moodle. So our classes, our classes are on Sunday, Tuesday, and Thursday from 8 to 9, same time. So please try to come on Moodle from in the given time. So today our lecture is about projectile motion. So if you have seen practice problem 3, so today we will solve some question from practice problem 3. This practice problem 3, PP3 mean practice problem 3, question number 3. So I will straight move to the problem. So first question is, a projectile is fired from the origin over the horizontal ground at an initial speed of 500 meter per second and a launch angle of 45 degree. So now the question is, when and how far away will the projectile strike? And the second part is, how high overhead will the projectile be when it is 5 kilometer downrange? And the third part is, what is the greatest height reached by the projectile? So this is the real life problem that we are solving. So first you must know what is given in the question. So read the question again carefully, and what is asked in the question, so you have to answer accordingly. Now, if you read the question again, what is given in the question? Question is a projectile. You know the projectile is fired from the origin. From the origin, okay, from center it means 0, 0, over the horizontal ground. Horizontal, there is a one horizontal ground, one so horizontal ground, it is very clear, at an initial speed of 500 meter per second. Now, if we come to the solution, now what is given? We have given initial speed. I denote this with as V naught. So V naught is equal to 500 meter per second. So that is already given as a question. So initial speed of 500 meter per second. So that is your V naught. And a launch an angle of 45 degree. And the angle is 45 degree. And I call this as alpha. So alpha is equal to 45 degree. V naught is equal to 500 meter per second. Why I have given here V naught or alpha? Because we will write formula accordingly. We can write here also theta, we can write here some other symbol, but whatever the symbol we will use in the formula, so that is why I am writing the same. But main thing is, this is your initial speed, which we are denoting with V naught, and this is the angle, which is 45 degree. Now the formula is flight time. So if we want to find, because what is the question? Question is, when and how far away will the projectile strike? Now there are two questions. One is when, and the other is how far away. So when mean, it means you have to find the time. When will the projectile strike? So it means you have to find the flight time, so which we denote with T, and the formula is 2 V naught sine alpha over G. So just substitute the value. So 2, the initial velocity is given as 500, 500, and the sine alpha angle is given as 45 degree, divided by G, which is 9.8. You know the value of G from your physics courses also. So this is 9.8, this fixed constant. So then 2, 500, the value of sine 45 degree is 1 over square root 2. So you simplify this and you will get 72.2 seconds. So that is the time T. So that was your first part. When will the projectile strike? So it means it will strike, projectile will strike after 72.2 seconds. And now in the first part, there is also another question. When and how far? How far? Now for this how far, we will move to next page. Now to find how far, The formula is range. It means you have to find the range. So the range R, the formula is V naught square over sine 2 alpha over G. Again, the value of V naught is given. You substitute value here. The angle is given as 45. So you multiply 45 degree into 2. So this will be sine 90 degree. So you take 500 square and you can write the value of sine 90 degree, which is 1, and divide by 9.8, and you will get 25510.2 meter. Because but the question was how far. So it means this will be definitely a distance. So it means this will be meter. So it means this total your range is 25510.2 meter. So this is the second part. So only if you know the formula, you just substitute the value. So then this question becomes very easy. Now, if we go to the again to the question, now what is the second part? Second part is how high overhead will the projectile be when it is 5 kilometer downrange? How high overhead will the projectile be when it is 5 kilometer downrange? Okay, now if you see this question, now we have another formula. If we want to find a position of a projectile, so the formula is R equal to V naught cosine alpha Ti plus V naught sine alpha T minus half gt square, and then this whole bracket and J. So this I and this J. And this R is a position vector. And what is position vector? We already know, if since R is xi plus yj, because this x component and this y component. So here if you compare this and this, so here you can see with I here this, here with ix. So it means your x will be this v naught sine alpha t, and your y will be v naught sine alpha t minus half gt square. So it is clear. Yes. Now your x, what is your x? So x is equal to v naught cosine alpha t. So since so therefore x will be equal to v naught cosine alpha t, and your y is v naught sine alpha t minus half gt square. So y is equal to this. Now in the question it was given how high overhead will the projectile be when it is 5 kilometer downrange. So it means your x is given 5 kilometer. Now if I convert, because the velocity was in meter per second and this is in kilometer, so I must convert this in meter. So 5 kilometer, if I convert this into meter, so this will be 5000 meter, because in 1 kilometer there are 1000 meter, so 5 kilometer will be 5000 meter. So that is why we must convert this. So 5 kilometer will be equal to 5000 meter, equal to your initial velocity is 500 and angle is 45 degree. So we can find from here time t. So if this you can divide on the other side. So 500,000 divided by 500 in cosine 45 degree. Now if you write here the value of cosine 45 and simplify this, you will get 14.1 second. But question was not this. Question was how high overhead. So it means you have to find the value of y. So if you find see the value of y is v naught sine alpha t minus half gt square. So v naught is already given, alpha is already given, t now we find from this, so which is 14.1 and minus half, and g the value is 9.8 and t is 14.1 whole square, and if you simplify this all, you will end up with 4020 meter. So I hope this is clear. Again I will repeat this. The question was how high overhead will the projectile be when it is 5 kilometer downrange. So it means from this equation you will find the value of t, and then here you will find the value of y. So that will be our solution. And now for the third part, if you see, the third part is what is the greatest height reached by the projectile. It means we have to find the maximum height. So what is the greatest height? So maximum height. So for this what we will do, again we will use another formula. So y maximum equal to v naught sine alpha whole square over 2g. So again you have to memorize this formula. So now you can substitute the values. V naught is given as 500, alpha is 45 degree, 2 into the value of g, we know it is 9.8. Yeah, you know the value of sine 45 degree is 1 over 2 square root, and so just simplify this all and you will get 6378 meter. So y maximum is 6378 meter. It means our question is now very clear, because what was our question? Question was, what is the greatest height reached by the projectile? So this is the greatest height where projectile will reach. So please go through again this question. I think it's very simple, very easy, but if you will solve 2 or 3 times, so then it will become even more clear. Now we can move to next question. So in practice problem 3, there is another question, question number 4. It is a projectile is fired at a speed of 960 meter per second at an angle of 60 degree. How long will it take to get 8 kilometer downrange? Now if you know the previous question, then this question become very simple, because you can see here what is your this 960 meter per second. It is our velocity. So 960 meter per second, you can write here meter per second, and the angle is given as 60 degree. Now the question is, how long will it take to get 8 kilometer downrange? Now if you see the previous question, what was our x? X was v naught cosine alpha t. So again your x is given, which is 8 kilometer. So you know 1 kilometer is 1000 meter. So 8 kilometer, if you convert into meter, so this will be 8000 meter. So therefore your x is 8000 meter. V naught is given as 960, and the cosine alpha is given as 60 degree. So and then you can find the time t. So if you simplify this all, it will be 16.6 second. Now again, if you read the question, a projectile is fired at a speed of 960 meter per second and an angle of 60 degree. How long? It means we have to find time. So it means it will take 16.6 second to get 8 kilometer downrange. Now next question is, find the unit tangent vector of the following curve. Find the unit tangent vector of the following curve. So the curve is given as rt equal to 5 sine t I plus 5 cosine 2 t j minus tk. Now here why I have written here first, because in question 5, if you see there are 3 parts. So other 2 parts you will solve yourself, so that will be your homework. So one part I am solving here. And now the question is, find the unit tangent vector of the following curve. If you remember from the previous lecture when we did dot product, cross product, in that lecture we also did unit vector. So the concept is same, and if you know the previous formula, so here the unit tangent vector formula is v over b magnitude. If you remember in the previous lecture when we were finding the unit vector, it was also like u over u magnitude. And here so the formula is almost similar. So unit tangent vector, so we denote with t, so it will be v over v magnitude. So what we need v mean velocity, and then we take magnitude of the velocity. So now since your curve r is given as 5 sine 2 ti plus 5 cosine 2 tj minus tk. Now so this is your position vector r given, so you know how to find the velocity from the previous lecture. So velocity is the first derivative of the position vector, so it means we will find dr by dt. So if you remember the previous lecture, the derivative of sine 2t is cosine 2t, and then derivative of 2t will be 2. So this 5 you will write same, and then similarly 5 you write same, and derivative of cosine 2t is minus sine 2t, and then derivative of 2t it will be 2, and minus the derivative of t, you know, it is 1. So therefore if you simplify this, so 5 into 2 is 10 cosine 2 ti, so this minus plus minus 5 into 2 is 10 sine 2 t j minus 1 into k, so minus k. So this is your velocity. Now we have to find v magnitude. So you know the formula of magnitude. So you write the square of first component plus square of second component plus square of third component and then square root. So tan cosine 2t whole square plus minus tan sine 2t whole square plus minus 1 whole square and then whole square root. Now if you take square of 10 cosine 2t, so this will be 100 cosine square 2t, then this will be 100 cosine square 2t, because you know minus 10 square, so this will be plus. So 100 cosine square 2t and plus minus 1 square is plus 1. And from here you can take 100 common mixture. So then this will be cosine square 2t plus sine square 2t and plus 1. We took 100 common from these two. And now you know cosine square plus sine square is 1. So similarly cosine square 2t plus sine square 2t will also be 1. And so we use that formula. So 100 into 1. So this will be 100, and 100 plus 1, it will be 101. So your V magnitude is 101 square root. Now our unit tangent formula is T is equal to V over V magnitude. So you just substitute the value. So the value of V is this 10 sine 2 ti minus 10 sine 2 tj minus k, and divided by V magnitude, which is 101 square root. Now you can divide this 101 square root to each. So it means 10 divided by 101 cosine 2 ti minus 10 over 101 sine 2 tj minus, because here is 1, so 1 over 101 square root k. So it is very simple. If you know the previous lecture, only what you have to do, you have to find the velocity vector, and then you have to find the magnitude of the velocity vector. Then you can find the unit tangent vector, which is V over V magnitude. So it's very simple. So please try to solve the other two part 2 and part 3. So that is your homework. And if you find any difficulty or problem, so we will discuss inshallah during our lecture on Thursday. So if you have any question, any problem, so we will discuss inshallah during our lecture from 8 to 9. But please try to solve, try to understand, so that you will get maximum benefit. Otherwise, if you will not solve yourself, and then the things will be very difficult. So please try to solve, and you must use your time in a best way. And the best way is, because now everyone is at home, so you can solve this question maybe 1 time, 2 time, 3 time. More practice. So mathematics need practice, so please try to solve more question, more problem. Then things will be more easy. So thank you very much for listening, and for having this lecture, and I hope everything is clear. Please be safe and take care of yourself and your family. Thank you very much. Assalamu alaikum.